Yeah, so as we've been working with our customers, we found a few different patterns that kind of repeat themselves. Each AI application and system is unique in a lot of ways, but there's some commonalities. We thought we'd share a couple of use cases, some case studies rather, of what we've seen before. But you could think of maybe four common patterns that pop up most frequently. So one, we're calling the drone, and that's essentially self-contained edge application. Those are scenarios where the whole logic of the system has to run on a single box. And scenarios where this might be common would be on a drone. In this case, we'll talk about an autonomous underwater vehicle. In those scenarios, you have to be really, really thoughtful about how much computing power you have access to and what you need your software to do. And it oftentimes means doing less than you'd like to because you have limited resources and a lot of constraints in your system. Another pattern that we've seen emerging is what I'm calling the factory. This is a scenario where you have kind of a backbone of cloud resources, but use cases and applications where you want to be able to run machine learning models on a factory floor in real time, and then interface those edge applications back into your cloud backbone. So how do you approach that? How do you think about those systems? The second is around kind of a network architecture. This is something that we've seen emerging in the telecommunications space, but really can apply to any scenario where you have multiple downstream computing environments that might be processing smaller pieces of data that are then being fed back out to a larger system. And then finally, another edge use case that maybe you might not consider being edge, but we think actually it fits really well in this pattern is the cluster. And that would be the idea of having multiple distributed data clusters. These could be Spark clusters spread across multiple locations. We found in a lot of industries, healthcare, life sciences, financial services, there are often Spark clusters geographically located in a lot of places. If you have a need to process data from multiple locations through a single set of models, some subset of models, actually becomes better to think about it as an edge application where you're sending those models out to those systems. So these are some of the patterns that you may find yourself in, and it's likely that the application you're building out would fit into one of these. So let's talk about one of these examples. So for this drone case study, we were working with underwater robotics operator. And one of the challenges they were facing is they needed a way to be able to test and then deploy target sensing algorithms, all sonar based, for improving the sort of self-operation of their autonomous drones. So what we propose and we work with them to build out is a testing and evaluation environment that can be run in the cloud, taking advantage of all the great EC2 nodes in AWS for various CPUs and GPUs that this drone operator could use to test out different AI model candidates. These were run against different test data sets, and essentially they could use the speed, efficiency, cost management tools that come with using this in the cloud to find winning models, and then using Modzy remotely deploy winning models out to their target device, these AI AUV computer systems, all of which come with a small Jetson accelerator. So you have this firm kind of footprint of how much computing resources are available. And so what we work with them to do is develop this remote delivery model where they can sort of at one time, using the Modzy interface Brad showed previously, send out their models to the whole fleet of drones. And those models will then take advantage of the hardware available on that Jetson compute unit while still leaving resources available for all of the other operational software that has to happen for this drone to do its job. Again, totally disconnected. And so this is where having a system that can not only survive but thrive in disconnected environments is a big part of how you have to think about designing your edge architecture. So with the system, it allowed this particular customer to rapidly iterate through the development and testing of new algorithms using all the great stuff that comes with the cloud, but able to much more quickly field those models. And then from a single click of the button, being able to update model versions or send in competitors out to their autonomous drones from one central hub, which again reduces the number of times you have to manually log in. As soon as those devices are back, reconnected to the network, all of a sudden you can get that telemetry data back into your central T&E environment and then use that for retraining. So when you're looking at a drone scenario, I would say highly consider taking all the advantage you can of what's available in the cloud, but using sort of thoughtful selection of what pieces of software actually end up making their way onto that drone or that single box device, including the actual application code. And this is another scenario where, as Brad mentioned previously, containerization provides a lot of convenience for making sure you've got a repeatable way to manage both your model code as well as your application code. So for the factory architecture, the case study that we'll be talking through was for human safety monitoring within an industrial environment. So one of our customers was looking for ways to better detect and even predict worker safety scenarios as they were playing out across a production facility. So detecting an event in real time might be noticing someone who's fallen or slipped or collided with a piece of equipment. This is something that can be done, and the real-time implications are very clear and very simple. An alerting system can be connected. There are other scenarios that they want to track, including using pose estimation to watch workers as they're moving around this space to see if there are health implications from perhaps how employees are moving, whether or not they're perhaps overexerting themselves, if they need additional assistance, even the use of exoskeletons to assist with the different job functions they have to reduce long-term health implications. So the way we approached this problem was by helping this particular customer take advantage of, again, all of the cloud resources they have within their Azure environment for centralized model hosting, testing, and evaluation, and for the deployment of new interfaces that their health and safety team could take advantage of. But then what we broke away was all the local data processing and local inferencing that is going to happen then right there on the factory floor. So using Intel NUC architecture for the actual inference processing, we connected a number of different cameras, pipelined those connections through the models per site for behavior and activity detection, and then use the MQTT protocol to really tie all of this stuff together. So this is a great example of why protocols can be really helpful, and choosing the right protocol for the job is an essential part of the system. In the case of IIoT, kind of industrial manufacturing environments, MQTT has a lot of benefits, and it means you can really reduce the amount of noise moving across the wire. So in this case, the MQTT broker really only hears if an issue has been detected. We don't have to pass all of the raw video data. We don't have to pass all of the model outputs to that broker for other systems to subscribe to that information. We can only send information about detected accidents and issues, or detected maybe poor form or improper technique considerations that would then be logged for future review. All of this information, by the way, is really being used for better training and better employee preparation, not for individual employee callouts by any means. And so we found that this separation of architecture really helped this particular customer meet the needs they have for providing a longer term, much safer environment for their workers, which ultimately also has financial implications of making sure that their production line does not ever go offline due to injured workers, as these are very highly technical and highly skilled employees. All right, so the last example I wanted to share here is a use case and a case study we've been working on with a customer that provides telecommunication services. The crux of the problem is that telco providers have invested a huge amount of resources into 5G infrastructure. And 5G infrastructure has powered so much of our economy, so much of our communications networks, but there was a real cost in putting all of this together. So how do these telco providers offer even higher value services that allow them to continue to pay off the investments that they've made in this hardware and these systems? And one of the emerging patterns is enabling their customers to actually use this 5G network to move models to the edge. So what we've been working on is helping this customer essentially have a centrally managed MLOps platform that their customers and partners can get access to load and deploy models, and then selectively launch those models to specific pieces of hardware that are geographically distributed. So this includes what are called multi-access edge computing hardware These are literal cell towers with a rack of servers at the bottom. They have a decent amount of power. And there's some real interesting use cases where being able to move a model to the base of a cell tower, so that my cell phone can actually get a model prediction, just based on how fast it takes for the 5G signal to go to the tower that I know is about a quarter of a mile down the road. I can get a faster, lower latency reaction if that model is right there at that tower than I can if the data has to make its way all the way to Ashburn, Virginia, where the cloud version of that model is running. So I think what's really interesting about this is it provides a way for this telco provider to offer its own machine learning capabilities that can operate right at the edge at a 5G tower or on their customer sites. But it also means those customers can introduce new opportunities to incorporate AI in real time right at their sites, maybe computer vision powered customer analytics or factory automation. They can get all of those benefits without having to invest on their own all of the infrastructure and resources to set up this kind of network-based approach.